Yes. Hello guys. Today in this lecture I'll talk about what are the trigonometrical substitutions and trigonometric transformations. Okay. Sometimes differential coefficients or differentiation is facilitated with the help of trigonometrical substitutions or trigonometrical transformations, right? Or algebraic substitutions or algebraic transformations, right? So algebraic transformations and trigonometric transformations sometimes makes easier the process of differentiation. That is the main purpose of how trigonometrical transformations or algebraic transformations or different or substitutions are must for understanding the differential coefficient. Okay, finding the derivatives. Now come to the point. So today I'm talking about differentiation with the help of trigonometrical substitutions, and trigonometric or algebraic or trigonometric transformations, right? So this is the objective of today, transformations. Now these substitutions or transformations makes the differentiation easier because it facilitates the differentiation process. Now come to that. Now these are the questions which I will solve, that how the substitution or transformation makes the question solving easier. Now let me take x equal to, we know this sine inverse y, let me take. Okay, here x equal to sine inverse y, we know that y is equal to sine x, right? Now substituting this value of y in this case, this first question, let me take the second one. Now substituting, putting value of y in first from second, in first from second. So value of y, if I substitute x equal to sine inverse sine x, okay, in place of y I substitute sine x. This is sine inverse sine x. Similarly, other transformations which are very helpful in case of finding out the solutions. Similarly, cos inverse cos x equal to x, tan inverse tan x equal to x, secant inverse secant x equal to x, or maybe theta, if I take any theta or the independent variable as theta, then it will be theta. Then cot of inverse cot, let me take theta equal to theta. Similarly, cosecant x inverse cosecant theta equal to theta. So whatever variable we are taking, in this way, these questions are very helpful. These transformations are helpful. Okay, and now let me solve those questions. How do we solve by substitution, trigonometric substitution, or questions of algebraic substitution? Okay, and now let me take one by one these questions. These questions are written down so that I can illustrate that how trigonometric transformations or substitutions are helpful to solve the questions. Okay, now the first question, let me solve. Here y equal to, we have cos inverse 1 minus x square upon 1 plus x square. Now we know that, what is the formula? Cos 2x or 2 theta is equal to cos 2 theta equal to cos inverse cos 2 theta equal to cos theta equal to 1 minus tan square theta upon 1 plus tan square theta. here we have to substitute x equal to tan theta. Substituting x equal to tan theta. Okay, so we get from first one y equal to cos inverse 1 minus tan theta, tan square theta upon 1 plus tan square theta, 1 plus tan square theta. Now this is equal to cos 2 theta. This is nothing but cos inverse cos 2 theta. This is equal to 2 theta, like delta theta. Now substituting value of theta, cos theta are taken this x equal to tan theta. So theta is equal to be tan inverse x is equal to 2 tan inverse x. Therefore dy dx now substitute differentiating it with respect to x, with respect to x, we get ddx of y equal to ddx of tan inverse x, ddx of tan inverse x, which is nothing but tan inverse x 1.126 2 upon 10 is for theta equal to 1 plus, sorry, tan for theta equal to this inverse of 1 tan for theta 2 upon 1 plus x square, or 1 upon 1 plus x square. 2 upon 1 plus x square is the answer. Okay, so this is your differentiation. This is how the substitution here in place of x in tan theta has made it easier. 1 upon 1 plus x square theta. Right? So this is differentiation of this one. So this is how substitution makes it easier to solve the question. Now let me take second question. Solve the second question now. So second question here is y equal to tan inverse 2x upon minus x. Now here we have to substitute x equal to tan theta again. So putting x equal to tan theta, why? Because tan theta upon 1 minus tan theta equal to tan 2 theta. You know that since tan 2 theta, sorry, 2 tan theta upon 1 minus tan theta, substituting x equal to tan theta, putting x equal to tan theta, we get y equal to tan inverse 2 tan theta upon 1 minus tan theta, and this is equal to tan inverse tan 2 theta, that means 2 theta only. Again 2 into tan theta means tan inverse x on the substitution. This is tan inverse x. Therefore differentiating it now with respect to x, differentiating it with respect to x, we get again ddx of y is equal to 2 into differentiation of tan inverse x with respect to x. This is 2 upon 1 plus x. Okay, differentiation tan inverse x is 1 upon 1 plus x square. The same way. This is the second differentiation. This is how we substitute. Substitution makes the questions easier. This differentiation easier. Now third question, let me take. Third is y equal to tan inverse under root 1 minus cos x upon 1 plus cos x. Now this is transformation. There is no substitution, but this is transformation. You know that 1 minus cos x equal to how much? Here 1 minus cos x or cos 2 theta. We discussed about cos 2 theta is equal to 2 cos square theta minus 1 and 1 minus sin theta. These formulae of cos 2 theta are very much helpful. In this case, 1 plus cos 2 theta equal to cos 2 theta, and 1 minus cos 2 theta is equal to sin theta. But in this case, 1 minus cos x, the angle is single. So it will be putting x equal to, sorry, nothing, we are just changing it. This is nothing but 2 sine square xy to angle is half. Single angle, it will be half. 2 cos square xy to 2 and 2 cancel out. You get tan square xy to and square root cancel out to tan inverse tan xy which is equal to xy. So differentiation now directly. Now differentiating it with respect to x, so differentiating it with respect to x, we get ddx of y equal to ddx of x upon 2 x only to 1 upon 2. Differential of x is 1 and 1.2 is constant to 1.2. 1 that means 1.1. This is the answer. Okay, so this is how the third question is solved. Now let me take the fourth one. Or the fourth question is to be solved. Substitution, trigonometric or algebraic, is helpful in case of differentiation or finding out the coefficient. Now fourth question, let me talk about fourth one. Here y equal to cot inverse under root 1 plus x upon 1 minus x. Now substitution. Here x equal to cos theta. Okay. Let x equal to cos theta. So theta will give us here cos inverse. But we know that 1 plus cos x again 1 minus cos x. So it will be cot inverse under root 1 plus cos x, cos theta, sorry, divided by 1 minus cos theta. Okay, so this will give us cot inverse. Now this 1 plus cos theta, just discuss about it. This is 2 cos square theta, right? This is 2 cos square theta, right? Divided by 2 sin square theta, right? 2 to cancel out, and this is cot square theta, right? Theta by 2, sorry, cos theta by 2. Cot theta by 2 only, it's going to be cancelled out. Cot inverse cot theta by 2. Okay, it's going to cancel, so this is theta by 2 only. And equal to 1.2, theta is cos inverse x. Okay, therefore differentiating with respect to x, differentiating it with respect to x, we get ddx of y equal to constant 1.2 into ddx of cos inverse x minus 1 upon in the root 1 minus x. Okay, that is there. So under root minus 1 upon under root minus x square. This is differentiation of this. This is how we differentiate these functions, converting them into simpler forms by substitution. Now next let me take the fifth question. For the fifth question, here y equal to cos inverse 4x cube minus 3x. Here we have to substitute x equal to cos theta. Why? Because 4 cos cube theta minus 3 cos theta equal to cos 3 theta. And this cancels out. So put x equal to cos theta. Therefore theta equal to cos inverse x. So putting here x equal to cos theta. So we will get y equal to cos inverse 4 cos q theta minus 3 cos theta. And this is nothing but cos inverse cos 3 theta. Formula of cos 3 theta is this. Okay, so this is equal to only 3 theta. This is equal to 3 theta. This is 3 into cos inverse x. Now differentiating it with respect to x. Okay, so differentiating it with respect to x, we get ddx of y is equal to 3 into minus 1 upon root 1 minus x here. Just calculator. Okay, so this is the differentiation of this one. Next, the sixth question, let me solve all the questions of these 10 questions, which are very much helpful in case of understanding this transformation. Okay, now let me take this one. These all questions are very important. They have come in separate exams or graduation in engineering as well as in graduation, okay, or BTech and sometimes in competitive examinations also, okay, for IIT and G. Now come to point. So sixth question. Let me take the sixth question. Y is equal to yes sine inverse 2x divided by 1 plus x. Now in this case, substitute x equal to tan theta, because we know that 1 plus tan plus theta is equal to x. When 1 plus sine is there, we substitute tan theta. Okay, so here putting x equal to tan theta. Alright, and then theta will be tan inverse x. So this will change into a transform this into sine inverse tan theta divided by 1 plus tan square theta, and this is nothing but sine 2 theta. This is formula of sine 2 theta. If I convert this into sine theta upon cos theta, convert tan into sine theta upon cos theta, the whole question if we solve, you will get 2 sine theta cos theta. Sine theta cos theta is sine 2 theta. Same formula will be obtained to this 2 theta. That means 2 into tan inverse x. Okay, so therefore now differentiating with respect to x, we get d dx of y equal to 2 into d dx of tan inverse x, which is equal to 2 into 1 upon 1 plus x square, or 2 upon 1 plus x square. Okay, this is how this question 6.1 is solved. So substitution or transformation makes the differentiation easier. For that, this facility is given to us. Okay, for that, I want to clarify this if they have copies examples. Now, seventh question, let me talk about. Where y equal to tan inverse cos x divided by 1 plus sin x. Now here, if it is sin x in the numerator, then it may be converted into cos x. Transformation. Change it into, let me transform this into, we know that sin pi by 2 minus x with cos x nothing else. That was according to geometry. Okay, or in coordinates. So this pi by 2 minus x is cos x. Cos x is changed into this. It means sin x divided by 1 plus, this is again cos x. So 1 plus cos pi by 2 minus x. I've changed angle. If I substitute cos pi by 2 minus x is also sin x. So sin x is also changed. In the numerator, what we get? Okay, in the numerator we get sin pi by 2 minus x. In the denominator, what we get? Okay, let me change it in further. Now sin theta equal to 2 sin theta over half of this angle. So this will be pi by 4 minus x by 2. This is cos pi by 4 minus x by 2. What is this formula? Now let me write here. We know that sin 2 theta equal to sin theta into cos theta. Okay, formula of sin 2 theta. If the angle is single, it will be sin theta by 2 cos theta by 2. In this way, I have converted this. So, dividing this angle, okay, we get pi by 4 x minus x by 2 to cos pi by 4 minus x by 2. Now, in the denominator, we get 1 plus cos theta. I just explained in the previous example. It will be 2 cos square. Again, half of this angle pi by 4 minus x by 2. The same angle we have obtained in the denominator also. So 2 and 2 cancel out. 1 cos is cancelled out. So we get 10. This is tan inverse tan of pi by 4 minus x by 2 angle. This is nothing but pi by 4 minus x by 2 angle converted into x, now or transformed into x. Now differentiating it with respect to x. Differentiating it with respect to x, we get ddx of y equal to 0 pi by 4. Differential of pi by 4 is 0 minus 1 upon 1. Okay, x differential of x is 1 minus 1 upon 2. This is the answer. So this question is solved 7 times. Now 8, 9, and 10. Let me solve them also. Very important question they are also. Okay, so this is how to transform the questions into simplification for differentiation. Now 8th question. This is so question number 8. We have y equal to tan inverse. Y equal to tan inverse the root x minus x divided by 1 plus x raised to 3 by 2. Okay. If I convert this into this is under root x, nothing else upon x or minus x are not changed. This I want to write down under root x into x. Into the power 3 by 2, that means 1 power x raised power 1 and x raised power half, that is under root x. So this is nothing but tan inverse under root x minus tan inverse x. You know that tan inverse of 1 or any angle theta plus something on this one, or let me take here x minus pi upon 1 plus x into y equal to tan inverse x minus tan inverse y. If it is plus sign, then it will be in the denominator will be minus. That will be tan inverse x plus tan inverse y. Okay, this is in this way. So it is automatically transformed into formation of this x. Now we can differentiate this with respect to x. Do this formula is tan inverse x and root x minus tan inverse x. This whole equal to this much. Okay, so this is how now differentiating it with respect to x. Differentiating it with respect to x. With respect to x, we get. So first is ddx of y. This is equal to now differentiation of tan inverse under root x. So 1 upon 1 plus x square, that means under root x whole square, 1 upon 1 plus x square. But now the root x is not x, so differentiating it again, it will be 1 upon 2 power half will come in the, we have to multiply into x raised power half. Okay, it was plus half and minus 1, that means minus half, so 1 upon under root x. Under root x will come in the denominator. So this is the differentiation. This is minus 1 plus x square, differentiation of tan inverse x. And now this differentiation under root x, we have differentiated under root x again by function of a function method, or chain by chain. First differentiation of tan inverse under root x, that means 1 upon 1 plus x square and root x whole square. Now let me write it. This is 1 upon 2 under root x in 1 bracket 1 plus x, the root whole square is x only, minus 1 plus x. This is the differentiation of this 8th question. Now let me talk about the 9th question. This is how substitution is helpful in case of differentiation. So our 9th question, question number 9, which is y equal to tan inverse, so in 2 parts, tan inverse y equal to tan inverse x upon 1 plus under root 1 minus x. Okay, plus second part is sine of 2 into tan inverse under root 1 minus x upon 1 plus x. Okay, so let me take these 2 parts in 2 different connotations. Okay, I have 2 parts. 4 minus x, okay, that is 1 plus. Okay, so let me take y is equal to, this is u and this is v. We will differentiate these 2 separately. And differentiation of y with respect to x will give us du upon dx plus dv dx. Ddx of u and ddx of v. Let me take this function as u and v. So instead of solving them separately, then we will add them to find out differentiation of y. Let me take u first. That will be equal to this whole function tan inverse x upon 1 plus under 1 half. Okay. Now in this substitute, or put x equal to sin theta. Okay, so x equal to sin theta or theta equal to sin inverse x we will get later. Put in this. In this case we get tan inverse sin theta upon 1 plus cos theta. Now this will be 1 minus sin square theta under the square root, that will be cos square theta, 1 minus sin square theta cos square theta, and square root will cancel to cos theta only. So this gives us tan inverse. I can write sin theta into sin theta by 2 into cos theta by 2. In the denominator we get 2 cos square theta by 2. 1 plus cos theta or 1 cos theta, then it is 2 cos square theta by 2 and 2 cancel out, 1 cos theta, but 1 cos theta cancel out. It is nothing but tan inverse tan theta by 2. And it is theta by 2, that means 1.2. Theta is sin inverse. Okay, so now getting du from dx, differentiating with respect to x, we get 1.2 differential sin inverse x is 1 upon under 1 minus x. Okay, the differentiation of this. First part, this is first question. Now second part is, okay, let me take the second part. In the second part, then we will get the answer of this by adding the parts. Okay, so that was 1.2. Okay, let me du dx was 1.2, 1.2, 1 minus x. Okay, right. This was differential of du upon x. Now let me take v equal to sin of 2 tan inverse root 1 minus x upon 1 plus x. Here let me take x equal to cos theta or cos phi, but theta we have already considered. Cos phi, we have phi is equal to cos inverse x. Okay, so this we have to substitute. Putting x equal to cos phi in this second transformation, we get sine of 2 tan inverse under root 1 minus cos phi divided by 1 plus cos phi. Okay, so we get sine of 2 tan inverse under root 1 minus cos. Now 1 minus cos phi is tan square phi by 2. Okay, this is under root 2 sine square phi by 2 divided by 2 cos square phi by 2 in the denominator. 1 plus cos phi is 2 cos square phi by 2. Okay, 2 and 2 cancel out, square root and this root cancel out, tan phi by 2. That means sine of 2 into tan inverse tan phi by 2. That means phi by 2, 2 cancel out. This is sine phi only. Sin phi in terms of cos phi. Okay, let me write it in terms of cos phi. It's nothing but 1 minus cos square phi under root tan value of sin phi in terms of cos phi. There is no need of inverse function in this case. It is nothing but under root 1 minus x square. Okay, in terms of cos phi, substitute cos phi equal to x. So in terms of x, it has been calculated. Now dv dx is therefore differentiating it with respect to x. Now differentiating it with respect to x, we get dv dx equal to square root of under root 1 minus x square. So this is 1.2 power will be 1 minus x square the whole half, but half power minus 1, that is minus half. Now different 1 minus x square again, so it's not x, it will be minus 2x only. 1 is 0, differentiation of 1, minus x square is minus 2x. So we get 2 into 20 now. So in this case we get x upon minus x upon under root 1 minus x square in the denominator. Minus x upon under root minus x square. This is the value of dv upon dx. The final answer is adding the two answers. Okay. Adding the two answers, this dv upon dx and dv upon dx is minus x upon under root minus x. So these are the two answers. Therefore, d by dx equal to du upon dx equal here dv upon dx. Putting both the values equal to 1 upon minus x square. And second is minus x upon under root minus x square. Okay. These are the 9th questions on the question. Now let me take the 10th question, which is the last one, and it will clarify that how we use substitution and transformation to solve the differentiations or finding out differential coefficients of some of the functions. Now 10th question last. In this case, y is equal to here tan inverse, okay, under root 1 plus x square, this, and plus under root 1 minus x square, sorry, divided by under root 1 plus x square minus under root 1 minus x square. Now in this case, okay, solve it easily. Let me substitute x square equal to cos of 2 theta, or let me take cos 2 theta. That will be easier. So 2 theta will be cos inverse of x square, or theta equal to 1.2 cos inverse x square. That can be solved easily. If I substitute x square equal to cos theta, so we get, for here 2 theta equal to cos inverse x square, theta equal to 1.2 cos inverse x square. If the value comes in theta, terms of theta, I will substitute, or we have to substitute 1.2 cos inverse x square. Okay, substituting x square equal to this, we get y is equal to tan inverse under root 1 plus cos 2 theta plus under root 1 minus cos 2 theta divided by the denominator we get again 1 plus cos 2 theta minus 1 minus cos 2 theta. Value of x square is equal to theta. So we get what? Tan inverse